right, so now we are going on to the second type of story problem that we will do today, and those are the consecutive integer story problems. First thing that we need is I'm just going to give you the key that you'll use whenever you have a consecutive integer problem. If you have a bunch of consecutive integers, like if you have two consecutive integers, you could use x and y for those variables, but that doesn't help you because x and y doesn't show that they are consecutive. So if you have consecutive integers, rather than x, usually use n. If you'd prefer x, that's fine. But if the first one is n, the next one would be n plus 1, and the next one would be n plus 2, and the next one would be n plus 3, and you just list off as many as you'd need. So if you needed 10 consecutive integers, you'd have n plus 1, n plus 2, all the way up to n plus 9. Consecutive even integers. So just think about these for a minute. If your first integer is n, then your next one would be n plus 2 because even integers are 2 digits apart. So you'd have n plus 2, n plus 4. Now if you have odd integers, don't get thrown off on this one. If your first one is n, if you're sitting at 11, how far away is 13? It's just 2 away. So regardless of whether you have consecutive even integers or consecutive odd integers, you can use n plus 2, and n plus 4 for your variables. I need to include just a little bit of a caveat here. I hate doing these this way, but I know that it makes it a lot easier, especially if you're in Math 990 and Math 1010. Some 1010 teachers will be a little bit of a stickler and have you do a different convention here. So if you use 2n, 2n plus 2, 2n plus 4, and then 2n plus 1, 2n plus 3, 2n plus 5 for the even and odd integers respectively, just know that that's there. But for this class, it's not quite as theoretically perfect to do it with the integers I have shown here, but it is a lot easier and I will allow you to do it. So let's say that we have 3 raffle tickets and they have consecutive numbers. If the sum of the numbers is that, find the numbers. So the first thing I'll do is make my key. I want to assign my variables. So my raffle tickets would be n plus 1, and n plus 2 because I had 3 tickets, so I list 3 numbers, and they are consecutive, so I use the consecutive integer strategy. Okay, it says that their sum is 2,666,031. Sum means add, so I'm going to add them all together, and I should get that big number. Again, solving the problem is not the hard thing here. It's just getting the equation, and that's what I want to focus on. There is your solution if you'd like to see it. Go ahead and pause it and take a look. Okay, and there it is big if you'd like to see it big. So now that I have n, I can answer the question. If n is 888,676, then the next raffle ticket is 888,677, and the next one is 888,678, and I get those numbers by just looking at my key. That's one reason it's so important to have a key, is so that you can go back and answer the question at the end. I have n, that's just the n I found. N plus 1, I would add 1 to it, and n plus 2, I'd add 2 to it. Okay, the house numbers on your side of the street are consecutive even integers. The total of your house number and that of your neighbors on each side is 1560. What is your house number? So if they are consecutive even integers, then I'd say they're n plus 2, and n plus 4 because I have 3 houses that I'm looking at. Mine's in the middle, so mine would be the n plus 2. Okay, it says the total means add, so I add everybody up and get 1560. Okay, solving that, I get n is equal to 518. So I want to use my key. It says the house numbers are n plus 2, and n plus 4, and mine is in the middle. So the house numbers are 518, 520, and 522, and mine's in the middle, so mine is 520. Okay, the sum of 2 consecutive odd integers is 28. Find the integers. So if I've got consecutive odd integers, they are just the same as consecutive evens, n and n plus 2. Sum. Sum means add, so I'd take n plus 2 equals 28. You're not always going to be adding, so don't get in the habit of just taking whatever's in your key and adding them together. So my solution is 13, and so my numbers are 13 and 15. I get those by just looking at my key. N and n plus 2 would give me 13 and 15. 3 consecutive even integers are such that the sum of the two larger is 232 more than 3 times the smallest. Find the 3 integers. Now this one is totally on purpose, made to look gross, but it's very easy. Just take it a step at a time. So the first thing we know is we need to do a key. In our key, we're going to have 3 consecutive even integers. So n, that's going to be the smallest. N plus 2 is next because these guys are even. N plus 2 is last, and he's going to be the biggest. If they were just consecutive integers, I'd have n plus 1, and n plus 2. But if they're consecutive evens or consecutive odds, I would have this for my key. So now it says the sum of the two larger. Well, n plus 2 and n plus 4, those are the two larger numbers. So I take the sum of them, I add them, and it is, that's equals, 232 more than, 232 plus, 3 times the smallest, 3 times n. I know the sentence looks horrid, but if you just take it a word at a time, it's not hard to get the equation. Okay, here's the solution, and we get n is negative 226, so we go back and look at my key. My numbers are n plus 2, and n plus 4. So negative 226 would be my first number. Negative 224, don't forget how to use positives and negatives, would be my next number. And n plus 4 would be negative 222. That would be the biggest of the numbers. Okay, that takes us to comparisons, and we'll do that in the next video.